Breaking news, every chemical and nuclear reaction doesn't work anymore. Engineering students from the University of Saskatchewan are currently working to fix the transportation of goods crisis due to the lack of gas working. With me, I have a specialist from these groups, Nicole. Hello, Nicole. Please tell us about this project you've been working on.
What we're trying to work on right now is we have a group of students working on a potential solution to this crisis. So some of the objectives that we're using to shape our design are to carry a total weight of 8.1 kilograms, to minimize carbon emissions from manufacturing, reduce total travel time to as small as possible, and then also transport a load within a specific target zone. Some of our constraints when thinking about this design is how we're going to be limited to a single leaf blower for our power source. It has to fit within a set dimension. It also has to not be supported by any surface outside of the rails. It also can only rely on the single leaf blower. It can't store any energy or use any electrical energy. We also have a budget for the scaled down design of $25. Now onto our ideation process. We've developed a few solutions together using a gallery method. These 4 designs, one of them being a tire idea where we have all the weight stored in a wheel that go down this ramp. Then another idea we had was a large funnel that would feed all of the air into a large plastic bag, which would push all the weight forward. We also had one that used a bunch of pinwheels at the back of it to just push and just capture all that wind. And then we also had a simple kind of ship idea. Since wind energy is used mostly for overseas, we thought maybe we could bring it just on land by adding some wheels on it. Selecting the idea that we wanted, we came up with some design matrices. Ultimately, our matrices showed that our wheel idea, while it came down to really close scorings, we found that our wheel on a ramp idea came out to be the highest scoring. So that's what we went with. Now from that, we started fabrication, as you can see here, filmed. And what we have now is kind of this iterated idea of our initial idea for a wheel and ramp system. As you can see here, here's our final design. The ramp, which was initially very large and adaptable to different heights, has now kind of just become optimized for the maximum weight and load. From our CAD, we really simplified down our idea down to mostly just structural items. So anything that wasn't really essential to design, we sort of cut just to cut down on emissions. And that's about what we had to show you here. Thank you, Eden. I'll pass it back on to you.
Thank you for your time, Nicole. Now we take you to Thomas, our on-scene reporter.
Thank you, Aiden. Today I'm joined by the team, Nicole and Jayana. So Jayana, how do you think that went?
Yeah, I think the competition went pretty well for the team. We had 2 attempts, which was nice, and both attempts reached the target zone. I think based on testing, we kind of knew what we needed to do to make it get there, so I'm glad it did. But there is room for improvement.
Perfect, thank you. And Nicole, how do you think you can improve on this design?
Well, I think that one of our biggest thefts of time was definitely our design just rolling back and forth because of the inertia from the weight. So what we saw from a lot of the other teams was a braking system that was built into their cargo system. So I think in the future, a braking system for ours to just make it more efficient in terms of stopping would really cut down on our time.
Perfect, thank you, Nicole. Aiden, back to you.
Thank you for tuning in. This has been the USask News Network. We hope to see you next time.